Hi all, welcome back to another session of Welcome Tutor. In this session, we are discussing some numerical based on integrated rate equation, order of the reaction, etc. First question, that is, for a reaction A plus 2B gives C plus D. The following data were obtained. First data, it is initial concentration A is 0.1 molar and initial concentration of B is 0.1 and rate of the formations of D is found to be 6 into 10 raised to minus 3. And second experimental data is 0.3 mole of A and 0.2 mole of B and rate of formations of D is 7.2 into 10 raised to minus 2. And third experiment, it is found that rate of concentration of A is found to be 0.3 and concentration of B is found to be 0.4 and rate of formations of D is found to be 2.88 into 10 raised to minus 1. And fourth experiment, it is found that it is initial concentration of A is 0.4 and initial concentration of B is 0.1 and rate of formations of D is 2.4 into 10 raised to minus 2. So from this data we have to find out the rate law expression and rate constant for the reaction. So first for this reaction, that is A plus 2B gives C plus D. We can write the general rate law expression as, that is, R is equal to K into concentration of A raised to X into concentration of B raised to Y. So we have to find out this X and Y, then only we can write the rate law expression. So from this experiment data, we have to write the rate law based on the concentration of A and concentration of B. So first experiment, we are taking concentration of A as 0.1 and B concentration as 0.1, and at that time rate is obtained as 6 into 10 raised to minus 3. So the rate law expression for the first experiment, you can write it as R1 is equal to K into concentration of 0.1 raised to X into 0.1 raised to Y is equal to 6 into 10 raised to minus 3. Again, coming to the second experiment, we can find that concentration of A is 0.3 and concentration of B is taken as 0.2. So again, rate is found to be 7.2 into 10 raised to minus 2. And for that rate law expression, we can write it as R2 is equal to K into concentration of 0.3 raised to X into 0.2 raised to Y is equal to 7.2 into 10 raised to minus 2. Again, for the third experiment, we found that the concentration of A is taken as 0.3 and concentration of B is taken as 0.4. Again, rate is found to be 2.88 into 10 raised to minus 1. So we can write the general rate expression as R3 is equal to K into concentration of 0.3 raised to X into 0.4 raised to Y is equal to 2.88 into 10 raised to minus 1. Again, coming to the fourth experiment, here concentration of A is taken as 0.4 and concentration of B is taken as 0.1 and rate is found to be 2.4 into 10 raised to minus 2. Again, rate law expression can be written as, for the fourth experiment, we can written as R4 is equal to K into concentration of 0.4 raised to X into 0.1 raised to Y is equal to 2.4 into 10 raised to minus 2. So from these four equations, we have to find out the value of X and Y. So consider the first and fourth equation. Here 0.1 raised to Y and 0.1 raised to Y is constant. Concentration of B is found to be constant. So when we divide the fourth equation by first equation, R4 by R1, we are getting 2.4 into 10 raised to minus 2 divided by 6 into 10 raised to minus 3 is equal to again K into concentration of 0.4 raised to X into concentration of 0.1 raised to Y divided by K into concentration of 0.1 raised to X into 0.1 raised to Y. Again here 0.1 common, we can cut, K cut. Again 2.4 into 10 raised to minus 2 divided by 6 into 10 raised to minus 3 is equal to 4. So 4 is equal to, again 0.4 divided by 0.1, that is 4 raised to X. So X, that is 4 raised to 1 is equal to 4 raised to X. So X will be equal to 1. Next we have to find the value of Y. So consider the second equation and consider the third equation. Here concentration of A, that is 0.3 and concentration of A is in the third rate equation also 0.3. So it is constant. So we can divide R3 divided by R2. That is third equation divided by second equation. Then R3 divided by R2 is equal to, that is 2.88 into 10 raised to minus 1 divided by 7.2 into 10 raised to minus 2 is equal to K into, here concentration of 0.3 raised to X into concentration of 0.4 raised to Y divided by K into concentration of 0.3 raised to X into 0.2 raised to Y. Here K constant similar, that is we can cut, and then 0.4 divided by 0.2 is 2 raised to Y is equal to, again 2.88 into 10 raised to minus 1 divided by 7.2 into 10 raised to minus 2 is equal to 4. So 4 is equal to 2 raised to Y. So 2 square, we can write 4 is equal to 2 square is equal to 2 raised to Y. So Y is equal to 2. So we got the value of X and Y as X is equal to 1 and Y is equal to 2. So the general rate equation becomes, that is R is equal to K into concentration of A raised to X into concentration of B raised to Y is the general rate equation. So here we got the value of X is equal to 1 and Y is equal to 2. So the rate equation becomes, that is rate law expression becomes R is equal to K into concentration of A raised to 1 into concentration of B raised to 2. That means the order of this rate law expression becomes 2 plus 1, that is equal to 3. So it is a third order kinetics. Again, secondly, they are asking what is the rate constant of this reaction. So after getting the value of X and Y, we can just substitute in any one of the equations. That is, first equation we can substitute. Here the rate is bound to be 6 into 10 raised to minus 3 is equal to K into concentration of 0.1 raised to, here X we got the value as 1 and 0.1 raised to Y value we got it as 2. So 6 into 10 raised to minus 3 is equal to K into 0.1 raised to 1 means 0.1, 0.1 square means 0.01. So 0.1 into 0.01 it is 0.001. Again 0.001 means it is 10 raised to minus 3. So we can cut both sides 10 raised to minus 3. So K becomes 6. So rate constant, in this way we can find the rate constant of the reaction as well as the rate law expression and order of the reactions from the experimental data.